Hello and welcome to our today's video tutorial. I'm Michael Kaiser, Director of Product Management and Innovations at CutOffTime Solutions, and today I will present the ARU 8500, a unit with a phased array antenna for direction detection for shipment verification. What will you see today? Today we will see the details about the ARU 8500. As I said, ARU, antenna reader unit. This is an RFID reader unit with an integrated antenna system. In this case, a phased array antenna where we have 3 separate beams. We will talk about the use case, direction detection. For example, when you have a loading gate, you have a warehouse and you have a truck, and you have to shift the goods out of the truck in the warehouse or vice versa from the warehouse in the truck. We'll talk about this use case with existing RFID systems, maybe also with sensors, and see the disadvantages of the actual systems. We'll talk about the advantages of the ARU 8500 for the direction detection. And I will present today a new parameter. It's a cutoff time to optimize the process with the ARU 8500. So you see here the ARU 8500. As I said, is an antenna integrated reader. We have a reader on the back side. It's more or less the ARU 3500. In front, we have this antenna system, and you see in total have around about 66 to 36 centimeter size, double the size of the standard CutOffTime readers. This phased array antenna is an antenna system where we can steer, where we control the beam. So we have one beam which we can steer in 3 directions, in 3 zones, and that's why we have this separation. We have one beam on the left, one beam in the middle, one beam on the right, and of course this will be done sequentially. This means we have permanently a sweep over these zones, and then we can separate our reading area, our reading zones in 3 different spots. Let's have a look to the use case with the standard gate. We have here the top view. This means we have an area where we can read, where the goods go in and out. We have an antenna on the left, we have an antenna on the right, and we move in this or in that direction. As I said, typical for warehouse truck situation, pre-production, final production in a production area, or in different zones in your warehouse or wherever you need this transition between zones. Of course, there's also the possibility to have 2 zones for detection in parallel. This means we have one zone antenna 1, antenna 2, and immediately we have a certain zone for antenna 3 and antenna 4. This will be used especially for bigger gates or when we have more tags, more transponders to check, or the transponder situation is weak. We have maybe some metal in between, and for this situation, you can do also shipment verification, direction detection on our crosstalk software. With our readers, you can run this. You have this for antenna, and also here you can identify the movement of goods. Today we will focus on this situation with 2 antennas, but everything I say here is also valid for the 4 antenna system. Standard gate, we have antenna left and right. We have a read zone. And very often this will be supported by light barriers. We have a light barrier on the left side, we have a light barrier on the right side, and so we can start and stop the trigger. This means when a forklift arrives, and you see on the fork of the forklift there is a small pallet, a tagged pallet, and when we start reading, so we break the first light barrier, the reading process is started, the workflow is started. We move forward. We are inside of the zone. The tag data will be read in this area from antenna 1 or antenna 2. By the way, of course, there is also a reader involved to connect both antennas to this reader. So we have 3 units. And finally, the forklift moves forward to the stop light barrier and stops the reading process. Because of the light barriers, we can find out which direction we have moved from left to right or vice versa. And when we stop the process, we can collect the data and then do the backend system. Standard gate, standard application, as you may have already used. So what can happen? Very often, this is in an area where we have limited space. This means it could be possible that a box, a pallet, or something else will be closed to be placed close by, and then the light barrier can be disturbed. In this case, we have a permanently triggered light barrier. You don't know when my process starts. Of course, the forklift driver don't take care for this. He moves, he has to load the truck. And in this case, maybe all your read results will not be valid because you don't know when it starts, how often you have passed this area, and that's why this could be a problem. Another problem is a so-called false positive read. A false positive read is a physical read. This means we read something, but it doesn't belong to our process. What could happen? For example, I drive in with my forklift, I break the first light barrier, the data will be read in my read zone, and then I stop this process and data will be transmitted. But the forklift driver wants to make a turn. He drives in and backwards out because he makes a turn. As I said, very often space is limited. And so in this case, we have broken the light barrier, we have started the process, we read the data, we transmit the data, but on this dock door, on this loading gate, there is no truck in front of, and that's why the data is wrong. Yeah, and the forklift driver don't care about this. He wants to have a turn, he wants to be fast. That's why he do this. But at the end of the day, your data process is wrong. You book this pallet to this loading gate, but in general or in real time, in real, you want to bring it to another truck. So how can it be improved with the ARU 8500? Again, top view. And the first thing is that the ARU 8500 can be mounted top view on the ceiling, top down. This means you can bring it on top. You have nothing on the left, nothing on the right. There's no danger of damaging these devices, and that's why the installation is easier. On the other side, you have only one unit, not one reader and two antenna, or one reader and four antenna, with four antenna cables, with 4 or 5 mounting kits, and so on and so on. You have to mount only one unit. That's why it's quite easy. As we have learned before, we have these 3 beams. You can handle these 3 beams, and that's why it's easy to use the system in this way. So a typical footprint of this system is 7 by 3 meters. This means the footprint of the loading gate can be 7 meters long and 3 meters wide. You can reduce this area by lowering the reader. So in this case, 7 by 3 meter, we have mounted the ARU 8500 approximately in a height of 3 meters, but you can drop down to 2.5 meters to get a smaller focused zone. What happened? So we have a box again on our forklift. We pass these areas, and then you see we read the box 1 first in the left beam, then in the middle beam, then in the right beam. And it could be possible that we read several times in each of these beams, and at the end we have a chronological result where the box has been through all these 3 beams. And you see, when we have passed this, we can collect the data and then to the backend. The error we have had before, one box is placed in this area, and the forklift moves again through my zones. And then you see in the zone with the left beam, we read box 1 and box 2, of course. This is a standard. And in the other zones, we read only the box 1 in the middle zone, in the right zone. So the box 1 has makes a transition through all these 3 beams. Box 2 was only visible in beam 1, beam left. That's why we can skip the data for box 2 because box 2 hasn't been moved. Box 1 has been moved, and so we can collect this data and transmit to our backend system. And for the false positive read, for example, we drive through, and again, the forklift driver wants to make a turn. He goes backwards again, and so we see left beam, middle beam, right beam, but immediately you can set up an value of for triggering 5 seconds, 10 seconds. When you have in the same period of 5 to 10 seconds, the middle beam and the left beam again, then you can take this data and can skip the data because this doesn't belong to a really workflow. And as I said, immediately you recognize this is a false positive read, and then you can ignore this data. Let's come to the cutoff time, a new parameter which we have added to make the reader more robust. We have the situation, we pass these gates, but in this case, in this left beam, we have a lot of boxes. This means that the reader has to read a lot in this area. It could be possible that it takes much longer. So in our case, only an example, in the left beam, we read 2 seconds, and in the other two beams, we read only half a second because we have only one box to read. This means that he stuck very long with the left beam, and it could be possible as long as it's stuck here, the forklift drivers past the other two zones, the other two beams, and then you can miss the data. That's why we have added the cutoff time. And in this case, we set it for half a second. So cutoff time you can set in milliseconds from 0 to 5 seconds. And then you can adjust the right value. This means it starts again in the left beam, but after half a second, it stops reading, stops doing the inventory at this beam, and moves to the middle beam, moves to the right beam. This could be possible that in the left beam, if you have a lot to read and you cut the time, that you miss some data. Yeah. In this case, you have increased the cutoff time to get more data to be sure this data is valid, but you can reduce again the timing for the middle and the left beam, middle and right beam, the same way. So we have no distortion, no problems in the middle and the right beam, and for the left beam we have to adjust the cutoff time that we have enough data, valid data, but not stucking, not gluing too long at this beam. So as a summary, you see the advantages of the ARU 8500. It's a phased array antenna system. It is steerable by the reader itself. We can build up the direction detection out of the raw data, quite easy to handle. The handling is quite easier. We have overhead mounting. We have to mount only one unit, yeah, and that's why it's quite easy. No impact of protection areas for the standard antennas left and right. The ARU 8500 delivers sequentially the data for the transition in a chronological way, so you know exactly when what happened, and with this data, you can build up the statistic on your own software, or of course you can also use crosstalk from CutOffTime to have this software from scratch and can use it immediately. We can automatically detect false positive reads. We see immediately if something doesn't belong to our process, doesn't belong to our workflow. We can skip the data, we can ignore the data. And finally, with the cutoff time, you see the acquisition is much more robust. We can limit the influence of a lot of text. And as I said, this is very often in limited in areas with limited space. And so we can reduce these problems which happened day by day with this cutoff time. Of course, you have to adjust a little bit, but with a little bit of experience, you will find the right values to do so. So many thanks for your attention. I hope you have got some more information for your use cases. I would be happy if you give me some feedback on the videos, and to say thank you and goodbye.